Welcome everybody to today's webinar. The subject of today's webinar is Geospatial Data Visualization in Python. So before we get started, a few logistics. This webinar is going to be recorded, and the recording is going to be available approximately 2 working days after today's session. In case you have any questions, feel free to ask those in the box. I will answer those questions after the webinar or at the end of my presentation and demo part. The webinar is going to take slightly less than 1 hour. And should there be more questions that I'm able to answer during that 1 hour, I will follow up with a blog post and you'll get a URL to this post after this session. All right, so let's get started. Oops. Slides are not moving. No, okay, now they are moving. Okay, so just in case that this is the first time you're joining this webinar series, let me just give you a brief overview over the topics that we have already covered and that will be covered in forthcoming sessions. So the first part was an introduction into geospatial analysis with Python for data scientists, and in this first introductory part, we gave an overview over what geospatial is in general. And the second part was a deep dive into Python GeoPandas build and dependencies. So how all the different components within GeoPandas, how they work under the hood. And the third part is where we are currently, is the geospatial data visualization in Python. This is actually a two sessions part. The first one was 2 weeks ago, and this is the second session on the subject of geospatial data visualization in Python. We will have 2 sessions in March on geospatial data wrangling in Python, which is very important for everyone who is doing any type of analysis. You need clean data, and how do you get there? You have to wrangle the data. Around April this year, we're going to have 1 or 2 sessions on working with geospatial data and scale, specifically on Amazon AWS. And the 6th part is going to be on geospatial data analysis in conjunction with machine learning. And this webinar series is brought to you by T-Systems, and it's powered by Knuth, which is a small data science consultancy. And in case you want to watch the previous sessions, they are all available on the T-Systems YouTube channel. And the URL to this channel is in the handout, which you can find in the box. So feel free to download the handout and keep it for the record and use it as we go. All right, so a quick refresher for those of you guys who participated in the previous session. This is no big news. But for those of you who are joining us first time, let me give you a brief overview over working with data in Python and how data is being processed in Python. So first of all, there is a slight difference in how Python handles non-geospatial data versus geospatial data. And so let's start with how Python handles non-geospatial data. And this can be data coming from any type of file. So as an example, a CSV file, any type of file that is holding tabular data. Now what Python does under the hood, it first of all refers to the data as a data series, which is essentially rows and columns of data. And that data series is being represented in a so-called data frame. All right, so this is how kind of the process of working with data as far as non-geospatial data goes. Now let's take a look at how that's different when you're working with geospatial data. The process is very similar. There's only one slight but very important difference. So you just grab a geospatial data file. An exemplary geospatial file could be, for example, a shape file or a GeoJSON. And Python refers to it as a geodata series, which is essentially also rows and columns of data. The only difference is that it also holds geospatial data latitude and longitude, obviously, right? And this data is being represented on a so-called geodata frame. Now, the big difference between how Python handles non-spatial and geospatial data is, whoops, to switch here. All right, so the big difference is that when you're working with geospatial data, Python requires you to have a separate column which is being created inside of GeoPandas, and this column is called geometry. Now, geometry holds the latitude and longitude data as an object. So that's a requirement for Python GeoPandas to be able to further process, which means to visualize and to analyze the data. Okay, now let's take a look at how GeoPandas, how the different components look under the hood. So this slide is going to save you tons of time because there's no documentation whatsoever on how the different components work together. So I'm essentially repeating this slide in every webinar, and the feedback that I got so far from the participants is that's one of the most valuable parts of this webinar. All right, so GeoPandas. There's a lot of libraries and dependencies that are working under the hood. And let me show you the most important ones, which you're going to actually work with. There is a bunch more, but they're working in the background with you even taking notice. So I'm not even going to mention them, just not to unnecessarily confuse you. So first of all, there's a library called Fiona, and Fiona's job is to read files containing geospatial data. Now, once the file is read, you need Shapely, which is a library for analysis and manipulation of planar geometric objects, but it's not for visualization. That's what Matplotlib is for. So Matplotlib, if you have some experience with Python under your belt, you probably already heard of Matplotlib, or maybe you already were working with it. That's the foundational library for visualization. Now, here's the trick. How do you get the Shapely data plotted onto Matplotlib? For that purpose, you need Descartes. And Descartes is a library which is built specifically to glue together Matplotlib and Shapely. Then there is CartoPy, and CartoPy is a library designed for geospatial data processing in order to plot maps and other geospatial data analysis. And it's built on top of NumPy. And NumPy is the fundamental library for scientific computing with Python programming language. It has support for large multidimensional arrays and matrices and a large collection of high-level mathematical functions to operate on these arrays. And there's one more library which I'm going to represent as a diamond, and that is Geoplot. And Geoplot is essentially an additional library that is built on top of Matplotlib and CartoPy to do some sophisticated plots with geospatial data. And we're going to specifically show you today how to work with geoplots. Okay, so there is a whole bunch of different ways to actually work with Python, and we recommend you should use Anaconda, which is the most popular Python data platform. But there's the devil's in the detail, and there's one thing you should know, that if you use the default repository that comes with Anaconda, you will run into problems and you're going to scratch your head and you're going to just wonder why things are not working. Now, the solution to this problem is that you have to install first the Conda Forge repo, and then in a second step, you have to deinstall the default Anaconda repo. And then in the third step, you have to install GeoPandas. And with GeoPandas, all the dependencies that are doing their work under the hood, they're going to be installed automatically. So it's a three-step process, and life is definitely better that way if you install the Conda Forge repo. Okay, so I'm going to switch now to our Jupyter notebook, and I'm going to walk you through the different kind of building blocks of working with geospatial data. Before I do so, I just take a look whether there are any questions from the audience. And I see there are none. Like I said, just feel free to ask questions as we go, and I'm gonna answer them after this demo part, which is gonna be approximately 20 minutes. All right. Okay, so we are talking today about geospatial data and how to work with it in GeoPandas. Now, the first important concept to understand is that Python GeoPandas actually works with layers of map. You can think of it very much like of a hamburger in the real world. Like you have a patty with your beef, and you have onions, and you have tomato, and all those kind of things, and they together construct a hamburger. So that's how I visualize, or how I kind of explain to myself how Python GeoPandas work with geospatial data. It's multiple layers of data that have different purposes, that have different formats, and that essentially together construct a geospatial visualization or analysis. Now, to start working with geospatial analysis in GeoPandas, you first need to create a geodata frame from a data set or file that we have. And I've showed this in the previous PowerPoint presentation, how Python is processing data. Okay, so you're grabbing data, and it needs to be represented as a geodata frame in case of geospatial data. In case of non-geospatial data, it's called a data frame. Okay, so then we can use Matplotlib's PyPlot module to plot the data. So let's start with a built-in data set available for free use from GeoPandas. Okay, so we're not importing any extra, we are, in this specific case, we're not importing an external data set, but we are essentially using a data set that comes along with the GeoPandas library. And it's a very simple data set that essentially shows the Earth. Okay, so the first thing that we need to do, we always need to import our libraries. And the convention when you're importing GeoPandas is that you're importing is at GDP. You can import it as ABC or whatever you like, but in order to avoid confusion when you're working with other team members on the same data set, it's better to use that abbreviation. This is commonly known in the Python community, so you should better stick with that. Okay, so import GeoPandas as GDP, and then you have to read the data set that is available within GeoPandas, and this is the way you do it. You just essentially create a variable GDF, we just call it GDF, and then you go ahead and do gdp.read file, and then inside the brackets, GDP dataset, get the path, and that's the name of the dataset that we're using here. Now, to make sure that the dataset is actually available, we use the so-called head method. So you go ahead and type gdf.head, and that way the first 5 lines of that data set are going to be displayed. Okay, so you see here, you have the population estimates, you have the continent, the name of the country, and most importantly for GeoPandas is the so-called geometry column. That's what I'm talked before about. And it might look a little bit cryptic to you. It looks like latitude and longitude, but it's not exactly latitude and longitude. It's just an object that is being created inside of GeoPandas in order to be able to process geospatial data. And without that, you're not going to be able to do any work in GeoPandas. So you need this geometry column. So make sure that when you're loading data sets and you apply the head method to see if the data, what data you have inside, you have to make sure that the geometry column is available. So that's very important. Okay, let's move on. Okay, so you can see the I just told that before, and okay, there's a few important things about plotting or visualizing you need to know, and I'll explain these here because they will keep on coming again and again, and essentially will aid you in understanding visualization. we will use Python de facto plotting library, matplotlib, to plot the data. And in matplotlib, plotting is a two-step process. It's first of all, you have to import the library, and then you have to tell it how to plot. We will import plotting module called pyplot for this. And we will use the magic command. Anything starting with this percentage sign is a magic command to tell it how. Okay, so let's walk it one by one. So first of all, we import the matplotlib and specifically the pyplot module, and we import it as a PLT. That's the naming convention for importing pyplot from matplotlib. And this magic command, just in case you're not aware of that, that is a command that essentially makes sure that the visualization or the plot is being displayed on your screen. Without that magic command, you will just not see anything. Okay, and then we just plot the data that we have imported from the library, and here we go. We have a nice little map of planet Earth, and as you can see, hopefully you can see those tiny little lines, so you can see the countries. Now, this is a little bit of a too microscopic visualization, so we're going to modify it a little bit, and we're going to do that by essentially changing the default figure size. And so the figure is always described in inches, and the first number is always the width, and the second number is the height of the figure. Okay, so we're changing that a bit so that it's more readable and digestible. And the world map you see is actually two layers. It's first the figure, and the figure is the layer which was created by matplotlib in the background, and then we displayed the geodata frame on top of it. So instead of those blue colored countries, as you can see them here, we can create another kind of layer on the top of the figure. For example, we can draw cities instead of countries, and let's do exactly that. So first, we just created a map that shows us the countries on our planet, and now let's create a visualization or a plot that shows us the biggest cities on Earth. Okay, so again, we are importing the data set, and this data set is also built in within GeoPandas. So this is not an external data set. And we are then providing a couple of arguments in order to plot this data properly. So first of all, the figure size, so is essentially this area here is the figure. So we want this to be 15 to 10 inches wide and high. And we use markers. So this is a scatter plot, and we use the diamond markers, and diamonds are represented by D. And as I just recently learned, Python, well, I actually know that Python is case sensitive, but it makes a difference whether you use a small d or a capitalized D, so be aware of that. That depending on the, whether capitalized or not, you will get a different type of plot. And I selected the color green, and the marker size is 10. So you can vary the size of the markers. They can be smaller or bigger, just as you wish for your convenience. Just proceed as you wish. Okay, so, and this scatter plot is a scatter plot of cities. And we can also have 3 layers of data. So as you can see here, we are having 2 layers. The first layer is not visible. It's the figure. The second layer is the map of our Earth. Now in this case, it's the same thing again. We have the figure as the first layer, and we have the cities as the second layer. Now we want to create a map that displays all 3 layers, which is the figure, the countries, and the cities. Okay, and that is relatively easy because what you just do, hold on a sec. Yeah, you just have to specify how you want this plot to be represented in your notebook. So you just define the the size of the plot, the color of the map, and the edges of the countries. And then you do the same with the second layer, with the third layer actually, which is the cities. So you want the markers to be round, the color to be red, and the marker size to be 5. Okay. Okay, so in this visualization here, in this plot, we are using matplotlib indirectly. And GeoData Frame is indirectly or internally creating the figure layer from matplotlib. And we can actually produce the same 3-layered map above by directly creating figures. So you will not necessarily do this in practice because it's an additional step. And why should you do something that that is being done automatically within GeoPandas? But I'm just showing it to you for just you know, to gain a better understanding of what is actually happening under the hood in GeoPandas. Okay, so this is kind of the manual process that that GeoPandas does automatically. Okay, so first of all, we are going to read the data set as we did before, so there's no big difference. And then we have to manually create the figure, and it does so by attaching an axis to it. So figure axis equals plot dot subplots, and then we define the figure size. And then we actually set the axis to equal. And these are the only 2 steps that GeoPandas that is being done in the background. Now we are just doing that manually, just so that you know what is actually happening under the hood. And then as we plot the 2 layers of the map, this looks very much the same. The only difference is that we set the first variable to axis. So this is how we display the world map, and this is how we display the cities. So this is kind of, you know, we just looked under the hood how GeoPandas, what GeoPandas specifically does. But like I said, in any type of work situation that you might encounter, you will probably skip that and you will just pick the convenient route, which is just let GeoPandas do the work under the hood. And this is just the 2 lines of code that you have to write. Okay. So now let's talk about map projections. Geospatial analysis has very many domains, and we're just mentioning a couple of the most important and well-known here, which is, first of all, flow maps, which you know, for example, such as Google Maps, ecology, which is a branch of biology, public safety, such as, for example, disaster management, social sciences, geology, and there are many, many others. And all the different domains, they require different kinds of geospatial data, and hence different kinds of visualization standards and formats have been in use long before Python was created. And they all use different kinds of CRS, which stands for Coordinate Reference Systems, though Cartesian Coordinate System is the most important of them all. And these different CRS are known as map projections. In visualizations, for example, in a geological survey map, in a geological survey, a map is generally represented like this. And this, for example, is known as the Albert's projection. And GeoPandas provides facilities to create such maps using CartoPy, which is a library designed specifically to work with map projections. And let's see how to create these. Okay. I have to switch a little bit between the webinar box and the Jupyter Notebook, so it takes sometimes a little time. Okay, so first of all, obviously, we import the libraries, and we are importing the coordinate reference system from CartoPy, and the convention is cartopy.crs SCCRS. So this abbreviation CCRS is the way we are actually importing CartoPy, or specifically the CRS module. Okay, so first of all, we're creating a figure of a certain size. So in this case, it's 7.1299 inches versus 6. And then we attach the projection details to the axis. We just have to use the projection's name and title. We do not have to create any projection by hand, or we don't need to write any code for that purpose. All details are already handled and filled up by CartoPy. So this is how we're actually doing this. And then we are adding the coastal outlines, and the shape of coastlines will be automatically adjusted to the kind of projection we created. So we're adding the coastlines, and then the shape, the size, and the types of the grids will be automatically chosen according to the projections. So these are the three components, and this is how it essentially then looks like. The map projection, as another example, understood by satellites, it's so-called a geostationary projection. So let's not just create such a geostationary projection. So you see only the projection name is changed, and the rest of the arguments, which is coastlines and grid lines, adjust themselves automatically. So first of all, you create a figure of a size of your choice. So this time it's 6 versus 6 inches. Attach a projection details to the axis, and then we change the color of the coastlines. So we just changed it from black to red, and then we just displayed it using this method here, and voila, we have a geostationary projection. So as you can see, you have different types of map projections, and we can only show you here just a few selected, but once you start experimenting with GeoPandas, you're going to see that there's a lot, and probably the exact type of map projection that you need for your purposes. Okay, let's talk about geoplots. Geoplot, like I said before, let me just go back to the PowerPoint, because I know it's a lot of content and it might be sometimes a little bit confusing. So let me just enlarge this for a second. Whoops, it's animated, so I have to walk through again. So Matplotlib is the foundational library for visualizations. CartoPy is the Python library designed for geospatial data processing in order to produce maps and other geospatial data analysis, which is built on top of NumPy. And Geoplot is this tiny little library that is built on top of CartoPy and Matplotlib. And now we're going to show you how to work with Geoplot. So Geoplot is a Python geospatial plotting library, and like I said, it's built on top of Matplotlib and CartoPy, and it's used by GeoPandas to do some really good quality visualizations. So let's start with a style of visualization called choropleth map. I'm hoping that I'm pronouncing it correctly. A choropleth map is in which areas are shaded or patterned in proportion to the measurement of some statistics, such as population density or per capita income. One color is chosen first. The darkest shade of the color represents the greatest number in the data set, and the lightest shade represents the least number. This is the most common method used to map magnitude. And we will draw a choropleth map of percentage of white population in New York City from free data available on GitHub. So this time we're going to import a data set, an external data set. But before we do that, we import Geoplot, and the convention for importing Geoplot is GPLT. And we are also going to import the CRS module as GCRS. And as you can see here, we just loaded and read the file, and that is a file coming from GitHub. And as you can see on the ending here, it's a GeoJSON file. And a GeoJSON file is a geospatial data format. Okay, so once we loaded the data, we just want to see what's inside. So we use the head method. So we see here the first lines are being displayed, and most importantly, the geometry column is there, and the geometry column holds the latitude and longitude data as an object. And this object is required for GeoPandas to be able to visualize and analyze data. Okay, So some simple math before we further proceed. So we want to visualize the percentage of the white population in New York City. So for that purpose, I'm just going to go back to make it a little bit more clearer. So we see the total population as of 2000, and we see the white population. And obviously, if we want to get the percentage, so we just divide one column by another. You would do the same even in Excel, right? So as a result, we get the percentage of the white population for each borough in New York City. And you can see those here. We printed them all out for each individual borough in New York City. So it's a total of, let's go down, 67 rows. Okay, so to understand how to use GeoPlot map plotting, you need to know one thing about the operations, functions, and methods used to draw the images. An operation takes several options, and options have two parts. The first part is the option title and name, and the second is the option value. And in programming, option name is called a parameter, and an option value is called an argument. And from now onward, we will use this parameter argument terminology. Okay, so let me show you the function, including the comments, and I'm just going to show you just a slight portion of the visualization. I'm going to move on later, but it's a little bit crowded here. So this function, which plots a GeoPlot map, takes many options. First option is always the GeoPandas data frame. So the GeoPandas data frame, that's what you see here. I'm just going to highlight it a little bit more differently. So I'm just going to, okay. So that's the GeoPandas data frame. Hue, and obviously the figure size. So how big do you want this plot to be? And in this case, it's 10 by 6 inches. Now, hue parameter tells which variable the plot is being plotted. So we want to plot the percentage of white population in our case, right? So this is here, okay? Then projection parameter tells what kind of projection we want. And in this case, we want an Albert's equal area. And then CMap tells what color you want to show. So we just selected purples, and you can select any other color that you like or better prefer. The line width is simply the width of the line dividing the different shades. And as you can see here, each of the boroughs is divided by a line, and that's this 0.5 line. The edge color tells the color of the line that divides the different boroughs. So we selected yellow. And then K stands for how many number of colors to use. And you can either use none. So this is what we did. And that way only one color is being used. And the legend is used whether to show the legend or not. And it can be set to true or false, just a Boolean value. And in this case, we set it to true. So we also see the legend on the right-hand side. And then we just further proceed with plt.title and the name of the data set, and voila, we have that visualization. So this is the percentage of white residents as of 2000 in New York City. And the darker the color, the bigger the percentage of the white population. The lighter the color, obviously, the smaller the percentage of white population in that given borough. Okay, so that's the fancy stuff that you can do with geoplots. We can also draw a basic version of a Sankey map. That's also something that can be done with that library. And a Sankey map is useful when you wish to show the volume of things moving between places. So for example, traffic congestion and inter-airport traffic volumes. Just think of like in Google Maps, for example. So let's do a Sankey plot of traffic on Washington, D.C. roads of year 2015. So in this case, we're also importing a data set, an external data set from GitHub that holds the traffic congestion data in Washington, D.C. This data is also represented in a GeoJSON, which is a geospatial data file format. And just to make sure that all the data that we need is there, we're just applying the head method. And in this case, we only display the first 3 rows. If you leave this space between the brackets blank, you will get the first 5 rows. But in this case, we want 3, so we put in 3, and that's what we get here. Okay, and again, most importantly, geometry is there, so we're good to go. Okay. So as usual, we have many options. And the first argument is always the geodata frame. So that's number 1. So you want roads and you want to define the fig size or the figure size. In this case, it's 15 by 15 inches. Then paths, this parameter requires the special geometry column we talked about, right? So it essentially grabs the geometry column that holds the latitude and longitude data as an object. Then we have scale. It's the type of thickness of the road, streets in a string format. And limits tells us the minimum and the maximum values of scale. So if we would leave this this option out, then all the lines representing the traffic congestion would have the same thickness. And so that wouldn't be actually very valuable because we want to see where's the most traffic, where's the least. And here's the plot. So this is Washington, D.C. And we see that the thickest lines, they represent the most trafficked roads, and the lighter ones are the ones where there's not that much traffic. And as you can see here, this is only one layer of data. So you don't see the map underneath it. Why don't you see it? Because we haven't plotted it. So always think of working with geospatial data in Python as of working with multiple layers of data. So whatever data you need, you just plot it. If you don't need it, you just leave it out. So in this case, we thought that in order to make this data set more readable, we will not plot the underlying map, but just the roads and the representation of the traffic congestion through different thickness of lines. Okay. And Geoplot gives us facility to map kernel density estimation, so-called KDA plots. So that's the next plot that we're going to show. And most of the time, a KDE plot is used on a small sample of data. And it shows the density of the things that we want to plot. We can show population density for one. Since we have already plotted population above, let's use vehicle collision data this time and do KDE plot on it. And we are going to actually plot 2 layers, one on top of each other. So the first, like I always said, is always the fig size. So that is something that is kind of plotted in the background. It's not visible. Then the second layer is actually the geodata that you're going to see, and in this case, it's the New York borough. So we're just plotting the boroughs. And then the third layer is going to be data showing collisions in New York. And that is an external data set. It's again from GitHub, and it's also a GeoJSON file, as you can see here. Okay, so this is a built-in data set built into the GeoPandas library. This is data that we're grabbing externally from virtually any resource that you wish. It can be GitHub, it can be Kaggle, or wherever you are having data that is of use for that purpose. Okay, so first of all, what we're going to do, we are going to print out the data, or just display the first 3 rows of the data. Geometry is there, we're good. Okay, so next step, Geoplot will automatically call matplotlib to create the layer 1, which is the figure. So that's happening in the background. And as usual, the first option to use is always the geodata frame. And then the shade parameter tells us whether to just draw lines or fill them with shades. And you do this by true or false. So we want shades, so we selected true in this case. And then shade lowest, this parameter can turn on or off the presence of low density shades. So very tiny little colors that are barely visible for the human eye, we turn that off by setting it to false. And the color that we selected is red. And voila, this is the map. Now, when you take a closer look, you're going to see that there is actually something wrong with the data, because the first plot shows New York, right? And New York, as we know, is to a large extent surrounded by water. And now we have the heat map representing the accidents that were happening in New York. And as you can see here, this heat map, it literally goes into the water. So we don't have any car accidents in the water, right? So the reason why we're having this kind of visualization is because the layers are independent, and KDA plot has circular elliptical lines, and it plots them fully like a complete circle. And we can clip those lines when they go out of boundary, and we can do that by supplying the special geometry column. So we do exactly the same thing we did before. The only thing we do is, hey, we want to clip the data and just look into the geometry column and make sure that all the data that is actually not relevant for our purposes, that is not displayed, or that the part of the plot that is not relevant, that is not displayed. And now we see that the heat map is in the exact boundaries of the city of New York. So no more accidents, no more car accidents in the water. Okay, so what's next? With this, we have finished the visualization part of Geospatial series. And remember, your analysis and visualizations are always as good as your data. And if data is faulty, then your visualizations are also faulty. And in the next webinar, we're going to talk about data wrangling, how to clean, process, and prepare the dirty real-world data so that we can have sound and reliable results from our data analysis. Because as you've seen here, the data was already clean and we just were able to load the data and work with it. Okay, so now let's take a look into the webinar panel and see if there are any questions, but I see there are none. So I'm hoping that everything was clear and that you're now able to make your first steps with visualizing geospatial data in Python GeoPandas. The handout that you saw is attached in the handout, so feel free to download that. And the recording is going to be available early next week. So with that, thank you all for joining us today, and have a great day, great evening, depending on your location. Bye-bye.